This session, the topic is Java introduction. Let me move on to JVM straight away. When you speak about the JVM, we all know because of JVM, Java becomes platform independent. So how it is happening? What is the architecture of JVM and how it is making platform independent? Let me get into that. So JVM has class loader. What is the input of class loader and what is the output of class loader? The input of class loader is the dot class file. Normally we will write the Java program and we will have the extension as dot Java. So the dot Java file first need to compile with the Java compiler. Then the Java compiler will generate the dot class file. For example, I'm having a sample.java file which is a Java code and it is being converted into bytecode. The bytecode is stored in dot class extension. So this process is happened because of the Java compiler. So now this dot class file is the input for the class loader. So how many varieties of dot class file can get into the class loader? We can take it into three levels. The first level is the bootstrap class loader. So that will have the top level dot class files. For example, we all know about Java lang package. Okay. I will be explaining that too in this video. So the Java lang package is at the top level. So if you want to load that one, then it will use bootstrap class loader. Then the second level, some of the jar files you might be seeing under the extension folder, ext folder, under libraries in your JRE folder. So those are the packages which you can import in your Java program for doing your operations. Those are not at the level one like Java lang package. Those are at the next level. Okay. So those one can be imported by extension class loader. Any file under ext folder, the jar files can be given as input. They can be given as input to extension class loader. And then the third level, the folder which I shown to you, sample.class, which is at your application level. Okay. This sample.class, which is generated because of the user defined class which I created. This is at the application level. So when this level of class dot class file, you want to give it as an input to class loader, then it will be a system or application class loader. So there will be three class loaders which will take the dot class file as input. Okay. So we know bytecode is stored in dot class file and that dot class file is taken as the input to class loader. Then how the class loader is producing the output, like what kind of output will produce? It will produce the output with the help of memory areas, execution engine, native method, Java native libraries. All these things are essential for doing this. So what kind of output it will produce? It will create a machine level code where the OS will have some instruction set. With that instruction set, that machine level code can be executed or can be understandable. Okay. So the OS is having, every OS is having certain instruction set with it. So according to the instruction set, we have to produce the machine level code. Then only in that OS it is possible to run. The JVM will produce exactly that. That's why your Java becomes platform independent. The bytecode will be converted to the machine level code according to the instruction set of your OS. Now, how it is doing? It is doing with the memory areas and the execution engine. So, what are all the memory areas are there? If you speak about the class area, you know Java is object oriented basis. It will have class. The structure of the class will be stored in the class area. Then what about the stack and heap memory? For example, you are creating a object for a class. The class name is sample. Object name is S1. So the object S1 will be stored in a stack memory. And the variables associated with the object, the memory, the actual memory associated with the objects will go into the heap memory. That means the object name will be in the stack and the actual memory for the object will be going into the heap memory. So this is the difference between the stack and heap. And then what is the PC register? That will have a program counter. That means if your program is having 10 lines of code, which line is being executed? Next, which line need to be executed? So that count will be stored in PC register. And native method stack will store the native methods. Native methods means the methods, the functions, okay? The methods which is written in C or C++ language. You all have to understand one more thing. JVM's core part. JVM's core part is written in C and C++. Okay. So that native method stack is there. Now, the memory is being in the middle part. Okay, done. Whatever you are storing in the memory need to be executed. Here the execution means the bytecode need to be converted to machine level code. That is what the execution I'm speaking about. So something is stored in the memory. That memory segment is over. How the bytecode is going to be converted into machine code? That is going to happen into with the help of execution engine. When you speak about the execution engine, again you are having three things. First, you are having one virtual processor. Like when you have one virtual machine, you can have one virtual processor to do the job, not that virtual processor. Second, interpreter. So this execution engine will have an interpreter. What the interpreter will do? It will take one by one every line and convert that bytecode to machine level code. Pakka. The bytecode is converted one by one into machine level code. Done. Then the third one in the execution engine is JIT compiler, just in time compiler. Then what is that? If you think about the interpreter, it does the job. Actually, the conversion is over. Then why you want to have JIT here? The only purpose to have JIT is to improve the performance. Then my question to you, how it is improving the performance? That means the speed of conversion. Interpreter is converting, fine. How JIT is improving the interpreter's speed? The answer is very simple. You all know some cache memory now. What is the advantage of cache memory? When something is happening repeatedly, you will be storing that in the cache. So whenever you want, you will get it quickly, right? In the same way, the repeated function calls or the repeated segment of code can be compiled by the JIT. JIT is a compiler. Remember, JIT won't convert. Okay. JIT is a compiler. It will have the repeated segments in it. Okay. When you have the repeated segments in it, whenever it requires, immediately it can be converted. Okay. Interpreter will convert every line by line. But whenever you are converting every line, you have to compile it, you have to convert it. But JIT compiler will have the frequently executing block of code ready for the conversion. Okay, ready for the conversion. It is compiled and kept ready. So your interpreter can use that for the conversion whenever it requires. In that sense, it is increasing the speed. Now, your JVM have to communicate with the OS. OS will have certain different languages also, like the programs will have in C, C++ languages also. And even JVM's core part is also having the methods in C++, C. So in that sense, it need to interact. The Java need to interact with the other programming languages. If you want to do that, then there should be one native method interface between them. This is all about the JVM and how it is making it as platform independent and how it is converting the Java bytecode to the machine code. Bytecode is initially happened because of the Java compiler, which compiles a program and makes it into the dot class file. And that dot class file is getting into the class loader. And from there, it is stored in the memory. Then the execution engine comes into play. It converts the bytecode into machine level code, which is stored in the memory. Right? Now, JVM architecture is fine. But why we have to use Java? Can we use C? Can we use C++? Can we use Python? Then why Java we have to use? Is there any difference in that? And which scenario we will go for Java? According to your scenario, you can choose your programming languages now. Then can you able to differentiate that? Suppose in a company they are giving you one scenario. You have to take a better language to do that. So which language you will pick? Is there any difference? How it works? To answer that question, let me get into the comparison. First, we will segregate the C and the object-oriented concepts. That means C is a non-object-oriented programming. That means no class, only functions are there. Okay. I used to say one example here. Like two persons are going to buy a same mobile, Samsung mobile. Okay. Or some mobile. Okay. The model and the mobile is same. One person is buying at the New Year time offer. Okay. 1,000 rupees, 10% he got offer. So the mobile price is 10,000. So he bought at 9,000 rupees. Another person bought the same mobile on the normal occasion where he paid 10,000 rupees. So in C program, what will happen? Normally in C program, you used to have a variable name cost. So cost equal to 10,000 you will make. Then one function will be there, billing function. So in the billing function, you will use the cost variable to print. Done. So there is one more function called return function. Why I am speaking about it? After few months, they found the issue in the mobile, and both of the persons, okay, person A and person B, we will have person A had bought in offer time, New Year time, and person B had bought the things in normal occasion. Okay. Now both the persons are returning the mobile phones. So you have to return the money as a owner of the showroom. Okay. So how will you return that money? Who will say how much money you have to return? The return function have to say. When you refer the return function, what is the cost value? There is one cost variable na. That cost variable will be 10,000. You have to return both the persons 10,000, 10,000, because there is a single function and single variable. The return function will refer the cost variable, and there is only one value stored in the cost variable, 10,000. So what is happened here? 1,000 rupees loss. Now you had this scenario before you. As a engineer, you have to make this somewhat interesting and somewhat efficient. Okay. And the shop owner should not get lost. That means the function, return function, is going to refer cost variable only. There is no change. But one variable, the variable name is cost only. It have to store two values. For person A, it have to store 9,000 rupees. For person B, it have to store 10,000 rupees. How it is possible to store? If you change cost equal to 10,000 for person B, then the first value 9,000 will be replaced, right? In that case, object oriented programming comes into play. How many objects you sold? You sold two mobile phones. Let me have phone 1 and phone 2, P1 and P2. Every object will have its own copy of variable in the class. Phone is a class. Okay, phone P1, phone P2. P1 is the object which will have its own cost variable. P2 is the object, it will have its own cost variable. Okay. Now P1 dot cost is 9,000. P2 dot cost is 10,000. Now also after 6 months, when the two phones are returned back, you will call the return function in the phone class. So now P1 dot return will refer the P1 dot cost, which is 9,000 you will be paying back. And similarly, P2 dot return will refer P2 dot cost, which is 10,000, you will return 10,000. So now the issue is solved because of object oriented programming. That object oriented programming is C++, Java and Python, which is not happened with C. And you know, in today's era, everything is object oriented only. You can see many scenarios which are very similar to what I had explained to you. That is object oriented concept. So you have to use C++, Java and Python on that occasions. So now, why C++ and why Java and why Python? The major difference between the C++ and Java is how the memory is being allocated and deallocated, and the usage of JIT compiler, and also the inheritance, the multiple inheritance, those things. You have to first understand the C++ using the manual memory allocation and deallocation. Java is using garbage collector, which is automatic memory deallocation. Memory allocation will happen during your object creation. Okay. Memory deallocation will happen during the garbage collector deallocates it. It is automatic way. It is very similar to your comparison of manual gear and automatic gear in your vehicles. Okay. Whenever you want to drive in the way which you required. You want to deallocate and allocate the in the way which you require, which is the most efficient way because that is the way you require. Then that is happened in C++. In Java, that won't happen. Allocation is in your hand, but deallocation will happen with the help of garbage collector, which is an automatic process. Okay. So the garbage collector makes your work easy, but at the same time, it reduces the performance a little bit. If you are very clear about it, how to allocate and deallocate memory, the C++ will give you most efficient memory allocation and deallocation. If you are not sure about it, then Java will help you with the garbage collector. So you can classify here the bigger applications and where the speed actually matters and where you can go in detail where C++ will work better with the expertise with the employee. And normal application development, your Java and Python will work better because of its automatic nature. And most of the things you can use the predefined things to integrate and to develop. When you speak about the application at the smaller scale or the mid range, definitely Java and Python stoops up than C++. And what is the difference of Java and Python here? In Java static, the word exists, the concept exists. But in Python, everything is dynamic. Java has static and dynamic. Python has everything dynamic. When you speak like static and dynamic one side and everything dynamic in the other side, then the memory efficiency will be more in which one? Java or Python? The memory efficient will be more in Java only because you are having a static variable which will consume lesser memory than a dynamic one because dynamic one requires object creation. Automatically your object will take some space, additional space than the static one. That makes Java memory efficient one. And Java is also faster because of this memory efficiency and in certain cases. But still Python is holding its hand on the top. Why? Because of lesser lines of code and lesser employability cost, I can say. CPU cost will be more in Python, but employability cost, like the salary you want to pay, for that salary, how much work you can extract, in Python you can extract more work. Because of the lesser code, easier learning, and faster the way the employee do the code. When you speak about the execution speed, that is different concept. I am speaking about the faster typing and the way we can complete the code quickly. So there Python plays a role. When you want to run the code more efficiently in the CPU, there Java plays a role. Okay. This is the comparison. We are going with Java now. Right. And memory allocation in detail, like stack memory and heap memory, I said. Suppose you are having a local variable in a method that will be available in stack memory. Suppose you are having a variable and its value at the class level. Variable and its value at the class level. So that will be available in heap memory. Variable value as a set. If it is inside the method, it will be in stack. If it is at the class level, it will be in the heap. The object of class. For example, let me have a class 1 here. Okay. So that you will be understanding a little bit more. Let me have one class here. Public sample is the class, and then let we have one function here. Function is fun one. Okay. So that's return type is void. There is no argument. Inside that, let me have some variable int b equal to 10. And at the class level, I will have one variable int a equal to 5. Better I will have another class here for better explanation. Public class demo. Class demo. Let me have this in a default scope. Let me speak about the access modifiers and all later. Class demo. In this class demo, I will have this. So now I will create the object for demo class. Demo space d1 equal to new demo. So d1 is the object. With the d1 object, we can call this function as well as we can access the variable a. When you say something like this, how about the memory allocation here? You think about only the d1 and this class and say how is the memory allocation going to happen? Which one will be in stack? Which one will be in heap? Think and answer. I will open a Excel file to demo to just explain you. Let me have a stack memory and heap memory. This is a stack memory and this one is a heap memory. Yeah. Stack memory is limited. Heap memory is not limited. You can go up to your hard disk space. Okay. You can be able to get a stack overflow error if some loops goes wrong. When you start to create more number of variables and when that reaches a threshold value, again I'm saying stack memory is limited. That's why you are getting stack overflow error. Okay. In Java. So now first you are creating the reference d1 that will be in stack, and d1 will have one memory. That memory will be in heap. For example, the d1's memory is h3, so this d1 will have h3 reference which will refer h3. This may have h3 too. We can say j3. So this is the memory of that d1 object. Okay. So in this d1, where will be the a value? A equal to 5. At the class level it is there. No? Where will be that? So that a equal to 5 will be in this heap memory. Now you are having a function fun1. Where will be the fun1 call? The name of the fun1 will be here. And that fun1 will have some set of statements. Sorry, the name of the fun1 will be in the stack. The function call will be in the stack actually. Okay, fun1 definition will be in I. Like the work, the execution will be in I. The function call will be in stack. Both are different. Okay, this is calling. Fun1 calling. If you want to call fun1, that calling is in stack. Okay. The fun1 actually the block is in heap. Okay. Now you are calling fun1. It is having one local variable. Where will be the local variable will be stored? During the fun1 call, the local variable b equal to some value 10 will be stored in stack. Will be stored in stack. Okay, all these are stack. This b equal to 10 will be under fun1 call. This is how the stack memory and heap memory plays a role. When the stack memory will get deallocated, when you call the function and the function execution completes, then this block will be deallocated. Assuming the function execution completes now. Okay, now this block will be deallocated. Okay, then when the D1 will be deallocated, when the program ends, that means when there is no need for the D1, that will go, right? When the heap will be deallocated, here only the garbage collector plays a role. It will be deallocated automatically, depends on some algorithms. That is a separate case. We will look into that separately. This place in C++ will be handled manually with the destructor. You can deallocate it. Here the garbage collector will do. Okay. Suppose you are having something like a string variable in your program. Let me have that string s1 equal to some value. Okay. Welcome. If you are having some string variable, how it is possible to allocate? In stack or in heap? How the value will be allocated? Where the S1 will be stored? Can you able to guess it? It is at the class level only. So class level means we all think that will be straight away falling under heap. Yes, it is falling under heap. Now, if I'm changing this, let me have two values. So S1 will be welcome. Welcome will not store like this, like it will be in different boxes. That is string pool. Later we will discuss. Let me type welcome now. Now I will have S2 also. String S2 equal to hello. So where hello will be stored and where S2 will be stored. It is at the function level, right? So that will be stored in stack. So in the stack, S2 will be there. But hello will not be there in the stack. Because whatever you can store in a single box only available in the stack. For example, a equal to 10. 10 you can store it in a single box. But hello you cannot store it in a single box because hello is a character array. Even though you are stating a string, HELLO, 5 box required. So it is a character array. It is linked We can easily say primitive and non-primitive data types. Int, float, these are primitive. String, some object creation comes under non-primitive. That means you will have multiple boxes to store the values, and you will refer the first box or the initialized box with one reference, and you can travel to other boxes with the links. Okay. So in that case, S2's hello will be stored here. In fact, it will store like this: HELLO, and the starting reference H5 will be referred by S2. So S2 will be in stack because it is inside the function, and it will refer H5. H5 will have H, and after H it will refer I. Okay. It depends on, it may follow the linked list architecture or it may follow the sequential storage. It depends on, okay, the array kind of storage I'm speaking about. So if it refers I, it becomes a data and a link, so it is a linked list. If it stores like this, then it becomes an array storage. But whatever it is a non-primitive storage which stores in a heap. Okay, and which is referred by the S2 in the stack. So this is how your stack memory and heap memory plays a role while allocating the values. This you have to understand in detail, because then you can do the efficient programming. Okay, now I also want to discuss about what is this public static void main. Why you are writing like this, public static void main? Why it is always public? Why you can't you use private static void main? See, public is an access specifier. The method main, I'm speaking about method main, I'm not speaking about function main, because this is inside the class. So we will call it as method. The method main should be called by a JVM. Okay. When it will be called, when you say Java space file name in the command prompt, okay, for the execution, JVM will do this. So when it calls, I'm not speaking about the compilation, I'm speaking about the execution, Java space file name at the command prompt. When JVM calls the main method, it needs to call na at that moment, the main method should be visible. So the access specifier should be public. If it is a private na, JVM is outside of this program. It cannot call the main method. If it is private, only the same object, that means only the objects which are within the class can call it. Okay. So then why static? Are you creating any object for the sample? Then are you calling the method like s dot sample space yes and s dot main like that? No. You want to call the main method directly from the JVM without object creation. When you want to call directly anything without object, then that should be a static. It is common for all the objects. It is at a class level. So you can call the method or variable directly without object if it is a static. Okay. With the class name itself, you can call. How JVM identifies the class name? With the file name only. That's why your file name and the main method class name should be same. Okay. So whatever your file name, it will use sample is the file name. So sample.main it will use. Okay. It won't create object for that. So that's why it is static. And if you change this to int, okay, and I can return 1 here. If you do like this, For an example, we will compile it. We won't get any error during the compilation. Okay, no error. But while executing it, you will get error because your JVM will call the method which is not returning anything. It will give you, it will show, it is saying that actually main method is not there. Okay. So to match that, it need to be void only. You cannot change. Then name of the method also should be main because JVM calls main. And then this string is just to receive the arguments from the command prompt. Okay. And this args is the array, like multiple arguments can be received from the command prompt and all can be stored in an array. This args is the name of the array. You can also have arg, okay, or args, whatever you wish. But it should be of a string type. Then, one more question I have to ask. We are using this string, na? This is a class because first letter is capital. Okay. Class means first letter capital will be. So we can identify that is a class, right? So string is a class, I had said. You are using the string class. Where is the definition of string class? Did you return any class like this? Class string. Like this, did you return any definition? No. So how you are getting the string class here? Okay. If you are not writing, definitely you have to import, na? Like this, you have to import. Okay. You are not importing also. Then how you are getting the string class? Actually, your JVM will import one package by default. Okay, one package by default. That is java.lang package, which is essential for Java program, mandatory. So JVM will automatically import java.lang package without writing the import statement. If you write also, no issue. So what will be available in that lang package? The string class will be available. And then the system.out.println, system, yes, capital na, the system class will be available there. And then any wrapper class like integer, float, those wrapper, I'm not thinking about static data types. I'm thinking about wrapper classes. That means object creation, integer space I, like that. Okay. So those wrapper classes will be in lang package, right? We have to understand these things. Now let me get back to our PPT. Like memory allocation, in detail we had discussed, and how the stack memory and heap memory will be allocated. So what we discussed today in this topic, we discussed about JVM. We compared languages, object-oriented languages with non-object-oriented language, C. And then in object-oriented language, we compared C++, Java and Python. In which scenario or what is the difference between those, where you can use those? Obviously, Python will reduce the employability cost. It will be faster to code, but Java is more faster to run and less memory occupation. When you compare the CPU cost and the employee cost, actually CPU costs are little lesser now because once you invest, but employee every month you have to give salary. So automatically some applications will fall under Python. And when you want something faster and something more efficient, it will fall under Java. And when you want something, you want to control everything in the application, memory allocation, deallocation, and very big application, then that will fall under C++. And when you want the efficiency of a JIT compiler, definitely it will fall under Java again, because C++ is not having something like JIT. So that improves the conversion speed. And finally, we discussed about the memory allocation in detail, the stack and heap memory. I hope so you had understood the concepts, the introduction to Java, and thank you.